All right. Hey, everyone. Welcome to another deep dive. And today we're going to be talking about something that sounds like it's straight out of science fiction,
Hmm.
but it is not. We are diving into the world of biohybrid robotics
Very exciting stuff.
and specifically, get this, a human-like hand powered by lab-grown muscles.
Yeah.
We're going to be looking at pulling our information from this fascinating paper from
Hmm.
Science Robotics. The title is a mouthful: Biohybrid Hand Actuated by Multiple Human Muscle Tissues.
Wow.
It was published, let me check the date, February 12th, 2025. So just last week. This is cutting edge stuff.
Yeah, very, very new research.
So get ready, because some of the stuff in this paper, I gotta say, is seriously mind-blowing. I was reading it and I was like, is this real?
I know. Well, what I think is really remarkable about it is that, um, we've seen biohybrid robots
Mm-hmm.
before, but they've been limited really
Yeah.
to, small scale things like really simple movements,
Right.
like, just tiny robots, like taking baby steps. This is something else entirely.
Right.
Building a hand with multiple joints
Right.
that can grasp and manipulate objects.
Yeah.
I mean, that's a whole other level of
Oh,
complexity.
yeah. It's not just moving forward and back.
Right.
It's like, okay, how do we bend each finger?
Exactly.
How do we grasp this? How do we hold a pen?
Right. And not only that, how do we get the strength and the control
Right.
to do something meaningful with that hand?
Right. So, yeah, this was obviously a huge challenge for these researchers.
Oh, absolutely.
But they came up with this amazing solution.
They did.
And it's called the MuMuTA,
The MuMuTA, yes.
which stands for, and get ready for this, multiple muscle tissue actuator.
Right.
MuMuTA.
It's a mouthful, isn't it?
Okay, so that already sounds complex. Can you break this down for us?
Yeah, well, it sounds complex, but it's actually, I think, quite elegant in its simplicity.
Okay.
What they did was they bundled together thin strands of lab-grown muscle tissue.
Mm.
Okay. And that's kind of like, how our own muscles are made up of these bundles of fibers.
Okay.
And this structure allows them to generate more force
Okay.
and more flexibility. So they're really mimicking,
So they're getting inspiration from nature.
absolutely, they're mimicking the incredible dexterity of our own hands.
That's really cool.
Yeah.
That's awesome. Okay, so they've got these bundles, they're mimicking muscles, but I mean, how strong are these MuMuTAs really? Can they actually get things done?
Well, let's put it this way. You know those little packets of sugar you get at a coffee shop?
Mm-hmm.
This hand could pick one of those up.
Really?
We're talking about, yeah,
Wow.
almost 8 millinewtons of force and about 4 millimeters of contraction.
Okay, and I want to remind everybody, I should have mentioned this earlier, this hand is not like a giant, robot hand.
No.
This thing is only about 18 centimeters long, so just a little over 7 inches.
Yeah, it's pretty small.
So a 7-inch hand could pick up like a packet of sugar.
Exactly.
Okay, so that's a decent amount of strength for something that size. But could it could it hold a pencil?
Well,
Could it write?
writing might be a stretch at this point.
Okay.
But I love that you're thinking about that because it really highlights the potential we're talking about here.
Right.
I mean, the MuMuTAs control the fingers of this hand through this, what they call a cable-driven mechanism.
Mm-hmm.
And it's a lot like the tendons in our own hands.
Okay.
So think about, you have a cable that runs from the tip of your finger
Okay, yeah.
down to your forearm. When your forearm muscle contracts, it pulls that cable, and that makes your finger bend.
Okay, yeah.
So the MuMuTA works in a similar way.
Okay, so walk me through this a little more. So we've got this cable mechanism. How does that actually make the fingers move?
So imagine you have these tiny cables that are attached to each fingertip,
Okay.
okay? And those cables are connected to the MuMuTAs.
Oh, right.
When the muscle tissue is stimulated with electricity, it contracts,
Mm-hmm.
and that pulls on those cables, and that causes the fingers to bend.
So they're not just making the whole hand clench.
No.
They can actually control individual fingers.
Exactly.
Wow.
And that's where things get even more fascinating.
Oh, boy.
Because by carefully placing electrodes on the MuMuTA, the researchers can actually control which muscle tissues are stimulated,
Oh, wow.
allowing them to move individual fingers, and that creates a much wider range of motion.
So we're talking like a full, range of motion, like what our hand can do.
Well, I mean, it's not quite there yet,
Okay.
but they were able to get the fingers to bend up to 130 degrees.
130 degrees.
Yeah, and with an angular velocity of like almost 500 degrees per second.
Whoa, 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 slow down, slow down. So that's pretty impressive, 130 degrees, but is that enough to be truly useful?
Well, think about it this way. They've already shown that this hand can perform like a scissors gesture,
Okay.
which requires pretty good coordination between multiple fingers.
Yeah.
And get this, they even had it manipulating a pipette tip.
What? No way.
Yeah. So imagine a biohybrid hand working in a lab.
Oh, okay, now that is seriously cool.
Right.
All right, so we've got these MuMuTas,
Yeah.
we've got the individual finger control.
Uh-huh.
What else? I mean, what else is like really mind-blowing about this research?
Well, they found that the way those muscle tissues are organized within the MuMuTA
Oh.
is
Oh.
super important for its strength.
Okay, well, how does that like relate to our own muscles?
Yeah, so think of it like weaving a strong rope. You need all the strands to be lined up neatly.
Okay, yeah.
And that's what they achieved with this, what they call the in-sheet method,
Hmm.
where the muscle tissues are cultured in this flat sheet,
Okay,
and then they're rolled into the MuMuTA.
gotcha.
And this alignment, just like in our bicep or any other muscle, makes the contraction much, much stronger.
So they're basically mimicking nature's efficiency
Exactly.
to make this biohybrid hand even more powerful. That's incredible. So did they like play around with any other, designs or like what other like interesting things did they find while they were testing this out?
Yeah, they actually tested MuMuTas
Hmm?
with different lengths of muscle tissues.
Okay.
Like, they tested up to 8 muscle tissues in a single actuator
Wow.
to see how it affected the force.
Okay.
So, imagine the possibilities of scaling that up.
Wow. Okay, now that's what I call a deep dive. So we've got this hand,
Yeah.
only 7 inches long. It can pick up, small objects. It can make a scissors gesture.
Mhm.
It can manipulate a pipette tip. I mean, what else can this thing do?
Well,
Is it going to take over the world?
that's a great question.
Maybe not yet.
Maybe not yet. Well, it's not, quite ready to take over the world just yet.
Okay.
There are, there are some limitations
Okay.
to the current design.
Right.
For example, it needs to be submerged in this nutrient solution
Mhm.
to keep the muscle tissue alive
Oh,
and
okay.
functioning.
Ah, so it's kind of like a delicate little hand that needs its special bath.
Exactly. And it needs these like little floats to keep the MuMuTas horizontal,
Oh.
which kind of limits how it can move.
Right.
Plus, the fingers, they can bend pretty well,
Yeah.
but they don't have a natural like return mechanism.
Ah, okay.
So after each movement, they have to be kind of manually reset.
Okay, so there's still some work to be done
Oh, absolutely.
before we see these biohybrid hands, like, out in the wild.
Right.
But even with these limitations,
Mhm.
it sounds like this research has, some seriously exciting potential applications.
Oh, yeah. Tons of.
I mean, imagine the possibilities.
Oh, absolutely.
What could this be used for? What are you thinking?
Well, think about how this could impact, you directly.
Okay.
What if, in the future, surgeons could use biohybrid tools
Oh, wow.
for incredibly precise procedures?
A surgeon with a super steady hand
Right.
powered by living muscle tissue.
Exactly.
That would be incredible.
And not only that, but, imagine a world where you could get a prosthetic limb
Right.
that feels, almost like your own hand.
Wow.
Prosthetics that are not just functional,
Right.
but also seamlessly integrated with a human body.
That's an amazing thought, to have a prosthetic that feels and functions, more like a natural hand.
Yeah.
It's incredible to think how this could improve people's lives
Yeah.
in such a tangible way.
And that's not all.
There's more.
This technology could also revolutionize drug testing
Okay.
and the way we study neuromuscular diseases.
All right, well, break that down for me.
So imagine, instead of relying on anatomy models or like static cell cultures,
Right.
you have this dynamic living model to test new drugs and therapies on.
So instead of looking at cells in a dish, they could actually see how a drug affects a functioning muscle system.
Exactly.
Oh, that's huge.
And because the MuMuTA is built from human cells,
Right.
we could even personalize it to an individual's genetic makeup.
Whoa.
Imagine, testing a drug's effectiveness
Right.
on a biohybrid model that's genetically identical to the patient.
Wow. That level of like personalization in medicine
Right.
would be a total game changer.
Absolutely.
So it sounds like this research is not just about building cool robots. It's also about pushing the boundaries of healthcare and medical research.
Yeah, it's about understanding how our bodies work at the most fundamental level
Right.
and using that knowledge
Yeah.
to create these new technologies that could benefit all of humanity.
It's inspiring to think that something as seemingly simple as a biohybrid hand, I mean,
Right.
could have such far-reaching implications.
Yeah.
But let's be real. I mean, there are probably still a lot of challenges ahead.
Oh, absolutely. Um,
What are some of the, the hurdles that
mhm.
researchers need to overcome?
Well, one of the key challenges is improving the longevity of the muscle tissue.
Okay.
Um, you know, right now they can keep the muscle tissues alive and functional for a while,
Mm-hmm.
but there's still, room for improvement.
So basically, like finding ways to make those muscle tissues last longer,
Right.
function more reliably over time.
Exactly. We need to make sure those muscles are in it for the long haul.
Makes sense. What about like the design of the hand itself? Are
Yeah,
there any limitations there that need to be addressed?
definitely. Remember how I mentioned that the hand needs to be submerged in a nutrient solution? It
Yeah,
has those little floats.
right.
Well, ideally, we'd want a more self-contained system,
Okay.
something that's more portable,
Yeah.
doesn't require constant maintenance.
So like a biohybrid hand that can operate out in the world, not just in a lab setting.
Precisely.
Okay.
And they're also working on, you know, finding new materials that could act as a natural, like, spring
Mm-hmm.
to give the fingers a way to return to their starting position
Right.
without needing to be manually reset.
That would be huge.
Yeah,
It sounds like there's a lot of exciting research and development ahead for this
absolutely.
technology. I mean, we've only just scratched the surface of what's possible
Right.
with biohybrid robotics.
It's amazing to think about how far this technology has come in
Yeah.
such a short amount of time.
It really does make you wonder what the future holds.
Yeah.
But for now, let's shift gears a bit and talk about, what this all means for the average person.
Right.
Why should we care
Yeah.
about these advancements in
Yeah.
biohybrid robotics?
Well, for starters, this research has the potential to revolutionize healthcare.
Okay.
I mean, think about it. New treatments for diseases,
Mm-hmm.
more personalized medicine,
Yeah.
and even, revolutionary prosthetic limbs
Right.
that could give people back their lost mobility and independence.
It's not just about building cool robots. It's about, improving human lives
Right.
in profound ways.
Exactly. And, beyond those practical applications,
Yeah.
this research also raises some really interesting questions
Okay.
about our relationship with technology.
Okay. Like what?
As the line between, living organisms and machines
Right.
continues to blur,
Yeah.
it really makes you think about, like, what it means to be human
Right.
in this rapidly evolving world.
That's a pretty deep question.
Yeah.
Yeah, it's it's wild to think, we're already starting to see this fusion of
Mhm.
biology and technology in action. It's like science fiction is becoming reality
It really is.
right before our eyes.
It's a remarkable time, I think,
Yeah.
for scientific advancement.
Yeah.
And as this technology continues to evolve,
Mm-hmm.
it really does raise all sorts of interesting questions.
Like what kind of questions?
Well, for example, what does it mean for the future of work?
Okay. Yeah.
Could biohybrid robots eventually do jobs that are currently done by humans?
That's a big question.
Yeah.
And one that we need to start thinking about seriously.
I think so, too.
It's important to have these conversations now so we can
Yeah.
prepare for the future
Mhm.
and make sure that these advancements benefit all of humanity,
Right.
not just a select few.
I completely agree. It's crucial to consider the potential impact
Yeah.
on society as a whole.
Yeah.
But, beyond the workforce, imagine the possibilities in other fields.
Okay. Yeah.
I mean, think about disaster relief or even like space exploration.
Oh, yeah. Robots that could like navigate these dangerous environments,
Right.
perform these like really delicate tasks,
Yeah,
and maybe even like self-repair using their own living tissues.
Exactly,
That
yeah.
would be game-changing.
right. Like I said, it sounds like science fiction,
Mm-hmm.
but it could become a reality sooner than we think.
Yeah, that's really exciting. And
Yeah.
it's not just about the practical applications either.
Yeah.
I mean, this research really forces us to kind of like re-examine our understanding of life itself.
It really does. I mean, blurring the lines between living organisms and machines.
I'm with you there. It's mind-blowing to
Yeah.
think that we're doing this. It really makes you wonder what other incredible breakthroughs are
Uh-huh.
just around the corner.
It really does. Well, we've covered a lot of ground today,
Mm.
from the intricate details of the MuMuTA
Yeah.
to the potential applications of this technology
Yeah.
in various fields. What are some of the key takeaways that you're
Mhm.
walking away with?
Well, for me, it's the sheer ingenuity of this research.
Right.
The fact that they were able to create a hand powered by living muscle tissue
Yeah.
and control individual fingers with such precision.
Yeah,
That's just incredible.
I agree. The level of precision is remarkable.
Yeah.
And for me, the biggest takeaway is the potential impact this could have on healthcare.
Yeah.
Personalized medicine, advanced prosthetics,
Yeah.
the new treatments for diseases. It's truly inspiring to
Yeah.
think about the possibilities.
Absolutely. And I think it's important for everyone to be aware of these advancements, even if they're not, scientists or engineers. This technology is going to affect all of us
It is.
in one way or another.
Absolutely. And it's not just about robots. It's about, like we were saying, the future of humanity
Yeah.
and our relationship with technology.
Yeah.
So for our listeners who are, eager to dive even deeper into
Yeah.
this fascinating world, we highly encourage you to check out the full research article.
Yeah. Good.
It's in Science Robotics. We'll be sure to include the DOI in the show notes.
Perfect.
And, as you continue to explore this topic, here's a final thought to ponder.
Okay.
Imagine a future where biohybrid robots are commonplace.
Okay.
They're assisting with surgery, working in labs, maybe even exploring other planets.
Yeah.
How do you feel about interacting with a machine? That's part living tissue
Right.
and part synthetic material.
It's a pretty profound question to consider.
It really is. This is just the beginning of an incredible journey.
Yeah.
And I, for one, am excited to see where it leads.
Well, thanks for joining us on this deep dive
Oh, thank you for having me.
into the world of biohybrid robotics. Until next time, keep exploring, keep asking questions, and keep your mind open.